For thousands of years, we've shared this planet with other animals, which have also developed languages, cultures, and rituals. But up until now, we've really had no idea about what they're saying. But that's changing now rapidly with AI. So in this video, I'd like to tell you what's been happening in this space and then ask a much deeper question about what that might mean for the way that each of us see the world. On April 14th last year, National Dolphin Day of all days, Google announced Dolphin Gemma. It's a large language model, the same basic architecture as the AI that you're already using. But instead of being trained on human text, it's been trained on 40 years of underwater audio and video of a specific pod of Atlantic dolphins. The dataset was built by Dr. Denise Herzig in the Wild Dolphin Project. She's estimated that it would have taken a human researcher over 150 years to manually analyze all of it and discover the meaningful patterns. But Dolphin Gemma did that in a fraction of the time. And it can now produce novel dolphin-like vocalizations, synthetic sounds that the researchers can play back to the dolphins to see how they respond. In the real-world deployment system, two divers swim alongside the dolphin. The system plays AI-generated sounds paired with an object that the dolphin likes. If the dolphin mimics the sound, they get the object as a reward. They're essentially teaching the dolphins a shared vocabulary. Google's own researcher said that if dolphins have language, then they probably also have culture. You're going to understand what priorities they have and what they talk about. So think about that for a second. What do dolphins talk about? Now let me take you to a forest in Japan. Toshitaka Suzuki is a researcher at Kyoto University, and he's been doing something that sounds very interesting, studying Japanese tits. I know a lot of others find this subject fascinating, but for completely different reasons. His area of interest is a small bird called a Paris myna, which is similar to a chickadee, or for those of us in Australia, a willy wagtail. What he found completely changed our understanding of animal communication. Suzuki discovered that the birds don't just make sounds, they use syntax. In other words, they combine calls in sequences to produce different meanings depending on the order in which they're produced. If you rearrange the calls, the birds respond differently. The same calls in a different order means something different. So syntax, that's the core building block of a language. And we really only thought that that was something the humans had learned to do. Suzuki took this further by broadcasting the sounds of birds warning each other of a snake. He then presented the snake to simulate to see if they would pay attention to it, and they did. So the birds heard the alarm call and paid more attention to the stick because they were picturing the snake. The call evoked a mental image. This entire field is what Suzuki now calls animal linguistics, and it's exploding thanks to the AI unlock. For the first time, we now have tools fast enough and sensitive enough to find patterns hidden in noise. Now, here's where I want to go with this, because every piece of coverage that I've read on this focuses on the science and the methodology and the model architecture. But nobody's asking the bigger question. What actually happens when we can communicate? We've gone from 40 years of manually cataloging dolphin audio that would take 150 years for humans to analyze to a model running on a Pixel phone that finds patterns in real time and generates responses. But the question is, what happens when a dolphin can tell us that their territory is being damaged by a shipping lane? Because we're not just building AI that talks to us, we're building AI that talks to them.